Okay, today's lesson is going to be on more percent applications. Today we're going to be looking at commission, fees, and percent error. We'll start with commission and fees. A computer salesman earns a 5.5% commission on each sale. If he sells 5 computers in 1 week for a total of $15,500, how much commission does he earn? So let's think about what a commission is. Commission is going to be an amount of money calculated. A lot of times it's on sales, in the sales industry. If you sell items, like in this case, he sold a total of $15,500, and he'll earn 5.5% of that for his salary. So we want to set up you could set up a proportion. You could calculate 5.5% of the $15,500. Either of those would be the same. So to set up the proportion, we start with the percentage that we're given. So 5.5 over 100. What part will be his commission over the total sales? Okay. So cross multiplication, and we will find that he will be earning a commission of, so let's take a look at that equation. So X would be equal to $852.50. Make sure that you put your labels. In this case, a salesman will earn a monthly salary of $850 plus a 9% commission on all sales above $6,000. 1 month he had a total sales of $11,875. What were his total earnings that month? So there's a lot of things going on in this problem. One, note that he's not making commission like the last situation. He's not making commission on the total sales, only total sales above $6,000. So sometimes you'll have a job, or the job will entail that there's a $6,000 like minimum, especially since they're giving him a monthly salary already. That's kind of taking care of that first $6,000 of sales. So we would have to first subtract the $6,000 from your $11,875 to find out the amount he will earn commission on, that the commission will be calculated. So the sales of $5,875 would be what he could earn 9% commission. So you can use your proportion. So 9% is equal to what part of 5,875? So your 100x is equal to 52,875. So his commission income would be $528.75. So they want to know his total earnings. And since they pay him a base monthly salary, we would have to add that in. For a total of $1,378.75. In this example, you're going to earn 7% commission on your sales, and your commission for the month was $438.79. So now we need to know the total sales. So when we are solving the proportion in the last few examples, hopefully you realized that we had a proportion that kind of looked like this. We had your percent over 100 was equal to your commission over the total sales, or the whole. The commission was the part, and the total sales was the whole amount. So they're giving us the percent, and they are giving us the commission. So it's the total sales, W, or the whole amount, W, I'm sorry, or T for total, W, doesn't matter which letter you use or which variable. In fact, you could use X, as long as you are understanding that the total sales for the month represents the whole amount or the entire original amount that the commission is paid off of. So if we set this up, we have 7 over 100 is equal to 438.79 over this total. Okay. So then we would have this equation, and if we solve it, we get our total is equal to our total sales of $6,268.43. Make sure you're doing these calculations along with me so that you understand where these numbers are coming from. Another example on commission and fees is that eBay charges an 8.75 fee to sell something on their website. If you sell an item on eBay and owe $7.75 fee to eBay, how much did you sell your item for? Similar to the last example, we have the percentage and we have the part that we paid, right? So whether it's a fee or a commission, it is the part of the ratio, not the whole amount. But that amount we pay is going to be part of the whole we sold the item for. So you have to have that part whole concept really clear in your mind to understand where these numbers are going to go and set up your work. Okay, over the whole amount or the total we sold our item for. So 8.75 W is equal to 775. So what we sold our item for was $88.57. You could always check your work by calculating what is 8.75% of $88.57, and then you could find out and see that the answer would work out. So check your work. Okay, let's look at percent error. When we calculate a percent error, we're actually going to be calculating percent that an estimate varies from the actual amount. So there's lots of places where we have percent error. Anything that we measure would have percent error. Anything that we estimate, anything that we guess. So those are all going to be kind of clue words when you're performing science experiments, when you are doing things that have the human element that can introduce some aspects of error, you will be calculating percent error for those. So let's look at the vocabulary. So we call the percent error the ratio that compares the inaccuracy of an estimate or the amount of error to the actual amount, and sometimes this actual amount is the accepted amount or the accepted value. So to find the percent error, we use this proportion. Okay, this looks very much like our percent of change, but the wording and the vocabulary, and you just have to get the precision down on where we're going to get the numbers and the amounts to fill in. So the amount of error would be the difference of the guess or estimated value to the actual value. So let's give a couple of these a try. So in this example, as a fundraiser, the Student Activities Council sold chances to guess the number of jelly beans. Brenda won the raffle with a guess of 370. So this is her guess, okay? And actually, there were 400 jelly beans. So what was the percent error? Okay, so the amount of error is going to be that difference. So we have a percent proportion. And we would subtract 400 minus the 370, and remember that this difference from the guess and the actual will be all over the actual value, which in this case is the 400. So we can simplify. There's a difference of 30 over 400, which gives us this equation. 400x is equal to 3,000, and when we solve for I don't know why I did that. We'll just keep it consistent here. P is equal to 7.5%. There was 7.5% between her guess and the actual amount. So this is just going to take some time and do a typed version in case my handwriting was a little bit too sloppy for you. Okay, let's go to another example. George is adding a rail around his back porch, and he estimates that the length of the porch is 13.5. So here's that word, estimate. So we know that there's going to be an error in that. He didn't actually measure it, but the length is actually 15 feet. So he estimated 13.5. So we have our percent over 100. And again, we're taking the absolute value of the error, so we always just subtract the smaller from the larger. And then the actual in this case is 15. So we get P over 100 is equal to 1.5 over 15, which gives us this equation. 15 P equal to 150. Divide both sides by 15. And we're going to get the percent equal to 10%. There was 10% error. So we'll go through. Not sure why there's an extra variable there. Again,